Good morning to all. In last few classes we started talking about pipelines, right? And then we stuck at a point that actually many of you did not understand that solution. Okay, so what I thought ki I'll pause for the time being that pipelining, and then I'll move to the much easier topic is something called control unit design. Okay, and again I will move back. I will cover that part in a class in future. So, in today's class basically in if you remember the first day's class, okay. So, we had a diagram is like block diagram of computer system. So, you can see here this is the block diagram of computer system, and then we say this is CPU, we have ALU, right, we have control unit, okay, and then we have what is called is like input output, and then we had memory, okay, main memory, okay. So, this is we say CPU, you should have a register also and so on, okay. This is very rough sketch, okay, no need to draw for you. So, basically ALU we have studied rigorously before mid-sem, okay, and then memory also we have studied, one class left, I'll do it. Now, we will be covering here in control unit design as I said, and then input output last two classes, okay. So, now we will be talking about how we can design the control unit. What is control unit? Basically the signal it pass. So, at this right moment that CPU wants to read it. So, that read signal it has to send. So, that is the control unit will do that part, okay. So, before studying in details control unit, we will see some basic processing part. Okay. So, when instructions are getting executed, what are the steps actually we need to do? Earlier also we said ki instruction has to be brought to the main memory, from main memory to CPU, and in that process what will happen? Instruction, because it is a instruction. So, whatever the program counter value that should be placed on the MAR, memory address register, and MAR will inform to the memory unit that it needs the data that instruction, and it will be brought and it will store to IR. Those things I said again, basically we revisit those things, okay, in this class. So, chapter is 7 in Hamacher, okay. So, it is very easy. So, just to read those things is very easy to read, okay. So, a typical computing task consists of a series of steps specified by a sequence of machine instructions that constitute a program, that has been discussed earlier also. Important is an instruction is executed by carrying out a sequence of more basic steps, that we will be talking about what are the basic steps. So, to understand that we will go through the details of within a processor. What are the registers, basic main register we already learned earlier, but how the data are transferred from one register to other register, and what is the important, that we will be studying in today's class here. So, what is the processor fetch one instruction at a time and perform the operation specified. So, let us say add instruction. So, it will fetch and do, we know this one. Instruction are fetched from successive memory location until a branch location occur, that is fine. Processor, this is very important, processor keep tracks of the address of the memory location containing the next instruction to be fetched using a register is called the program counter, okay. And there is important register is called the instruction register. So, while executing a program, how things goes? First is fetch the content of the memory location pointed to by the program counter. So, that could be written that whatever the value it will be there in the program counter, and whatever their value will be there, program counter will be loaded. So, PC this value will be loaded to MAR, okay, that is memory address register, and after that whatever the value will be there in particular location in MAR, so that will be transferred to IR. So, that is in total it is written that IR will be filled with the value pointed by the program counter. So, now as I said that program counter always point to the instruction which will be executed next. So, once that instruction is brought to the CPU, So, now program counter will point to the next instruction. So, we assume the next instruction will be in the next location. So, if it is the word size is 4 byte, so therefore, next location will be plus 4. So, therefore, whatever the value is there, it should be added with 4. And you have to have the idea that any operation happen, it should be ALU would be involved, because ALU is the only circuit where we can do addition, subtraction, any logical operation, shifting and so on. So, program whatever the program counter value, that will be added with 4 and then it will be stored to the program counter. Okay. And then whatever it will decode the instruction, and then whatever the operation is there, let us say addition, so that needs to be done. So, very what is called abstract way, these are the 4 steps for executing the program. So, to understand how things happen, so we need to understand this diagram. Okay. What is this diagram? This is the internal diagram within the processor. Okay. So, here we have a internal processor bus. See, you won't get marks for drawing this picture, but if you do not understand and you do not keep in your mind this one, so you cannot answer the next question. So, therefore, what you have to do? So, you need to understand each figure. So, as I said, the minimum register, a processor number of minimum register will be like one is the program counter. So, this is the program counter and it is a bidirectional. Why bidirectional? You need to remember the logic, then only you will understand whether it is a bidirectional or a unidirectional. Why? Program counter value will go to the MAR. So, as you can see, there is a link between program counter with MAR, memory address register, and it will be unidirectional. From the day one I said that memory address register will be unidirectional. So, therefore, as you can see, this is the only one diagram here, one arrow, right, not, but in case of the program counter it is both way. Why it is both way? You just understand ki program counter value will go to the MAR. I wrote program counter value will go to the MAR. So, this should be right arrow according to the diagram, and next again I said this one. So, this value program counter value is getting increased. So, therefore, it should be in both way. So, it should be program counter this side and it should be also both way. Next I talked about MDR. What is MDR? Memory data register. Okay. So, memory data register basically communicate information or data between outside of the processor like memory and to the CPU, that also taught in the beginning classes. Okay. So, here is MDR and it is both way. So, therefore, it should be connection should be like this one, and similarly also with the outside world. So, you can write, you can read from the memory. So, therefore, this should be read and write. As you can remember, MAR is only unidirectional because address line is always processor to outside world. So, therefore, it is unidirectional. Now, we have a basic thing, very important thing is like ALU, arithmetic logic unit. So, here ALU, so mostly if you for simplicity you consider that we need to do addition subtraction operation. So, that is a binary operation. So, this is the operand and this is the operand B. One operand will come directly through the internal processor bus, other will come through this path. What is this path? And then we will realize why it is so. So, there is a register here, Y register, it is coming here, there is a mask 2 to 1 mask, and then either you can select a 4 or you can select the whatever the value is there here. Okay. And then you have the ALU, and then ALU is a combinational circuit, right. So, it cannot store the result. So, therefore, whatever you add it, it needs to be stored. So, therefore, there is a register is called the Z register, and then there are some other temporary register for intermediate operation, and there are register R0, R1. On the right side, there is something called instruction register, that I just said ki instruction should be brought from the main memory to the instruction register, and then it needs to be decoded. So, therefore, this is instruction decoder and the control logic. So, after that it will generate the control signal. So, that now we will study how this control signal is getting generated. To to study this one, you need to remember this diagram here. It is very simple diagram, it is only with the single bus. If you have a multiple bus, then we will have a more complex diagram, but not today's class. So, therefore, if you have any doubt at this point, so what you have to do, you have to relate logically, you have to feel we should have a program counter can be updated, and program counter also will be linked with MAR. So, it should be bidirectional. Okay. It is not only that, in next slide we will be talking about there will be a control, whether it should in or it should be out. If in is 1, then it will go, otherwise it will not go. Okay. So, and then this is memory address register, MDR, and then for ALU it has either it can choose this one or it can choose this one. Why it is constant 4? Because we assume that next instruction is there in the next memory location. So, sorry, word length is actually 4 byte. Okay. If it is 4 byte, that means first instruction if it is there in 1000 memory location. So, 1001, 1001, sorry 1000, 1001, 1002, 1003. So, 4 bytes, next is 1004. So, therefore, initially say let us say this is the 1000, program counter will go here, that is a MAR, and then it needs to be incremented. So, therefore, it will be same value will come here, that is 1000, and it will select constant 4. So, it will come and it will add it 1004, and then this again in the next clock cycle it will be stored the 1004. So, this is the point. So, that is why key this 4 is written. If in question if we ask that word length is 2 byte, so obviously it should not be 4, instead of that it will be 2. Okay. Or if it is 1, so next instruction will be in the next memory location. So, this is the explanation. ALU, whatever I said is internal organization of the processor, this slide is talking about that. Okay. So, therefore, I can skip here. So, I know the what is the task of the program counter. So, it keeps track of the execution of the program. We have a MAR, it holds the address of the location to be accessed. Okay. MDR is a special thing, that is it communicates between outside part and then internal memory. If you want to get the data, so you have to use the MDR register. So, it contains data to be written or read out of the address location. It has 2 input and 2 output. We will see that MDR specially part. Okay. So, register, there are multiple registers, some of them are called temporary register, that programmer cannot access. Okay. And we have multiplexer, you have the choice, either you can choose constant 4 or you can choose the other thing. Okay. That is why other input that is coming from the register Y. So, operations for any instruction for execution, some of the operations are involved here. What is? We need to transfer a word of data from one processor register to another processor register. So, always you need to remember the diagram. What is this diagram? So, this diagram we had something like that. Okay. So, and then and then we had a register is called temp. Okay. We have a set of register R0, R1. So, this is something like that, and this in you have a program counter, you have a MAR. Okay. So, this is something you have a MDR. Okay. So, that is bidirectional both sides. So, this is connected to the memory unit. So, this diagram you have to understand very clearly. Okay. So, basically any instruction execution, what basically happen, any one of the things happen, or it may be multiple things also. So, I mean to say that more than one operation will happen. So, transfer a word from data from one processor register to another processor register, that happens. So, after the results it may happen that you need to store the result from Z0 to R0, okay, from one register to another register. So, these are the operation here, perform an arithmetic operation and logical operation, obviously that is the main objective. So, it will happen in the ALU, as I said. Fetch the content of a given memory location, we need to fetch the data, not only the instruction. We sometimes within the instruction we have the memory location, we have started in addressing mode. So, you have to fetch the word operand also from the memory, and obviously you have to store the data from processor register to particular memory location. Okay. So, these are the operation generally happen in the during an execution of the program. So, next what we do it for, let us say for this operation. So, when we want to transfer data from one register to another register, internally what are the control logic we did, okay. What are the things we should do or processor does, that we look into. Similarly, for when we need to do the arithmetic operation, how LU is performed and what are the other logic, other control units, control signals needs to be generated. Okay. So, that we will see. So, here is simple, we want to transfer content from one register to other register. Okay. So, you have to remember this diagram, again we are back to the diagram, but it is like much more detail. So, let us say we have a register, it can be a program counter, it can be other register. So, we will have two control line, one is for in, another is for out, okay. If it is bidirectional, okay. If it is bidirectional, it will be like that, okay. Here see what you do it. So, some of this, in this case what we see is there is a control part, if it is 0, okay, then no data will go to this register, and if it is 1, then the whatever the value it will go to the internal what is called is processor bus. My point is that most of the register, what we want to input that register or what we want to take out the from register, we can control using the two signal, one is called RI, that is register associated with RI in. If RI in is 1, so then whatever the value is there in the control internal bus, processor bus, those value will come to the RI, otherwise it will not come. Similarly, here after the results, if we want to store the value here, so it should be Z in, and when we store the results, we want to pass the result, then we have to put Z out. So, now you take a simple example, what I said. So, you need to do PC equal to PC plus 4. Ideally what you should do, PC somewhere here you have a PC program counter, so that should be in, program counter out should be on, then whatever the value it will be placed on the internal bus and then it will come here. Then what you do it, control select this part. So, it will come here, this is 4, this is program counter value, and then you give signal, this signal key you add it. So, add is a signal, and then whatever the result is there, you have to put Z in equal to 1. So, result will store here, and then you have to tell key Z out, Z will be out here, and then program counter in should be on. Earlier it was program counter out, now program counter in. Okay. So, these are the operation you need to do for only for PC equal to PC plus 4. So, here, but what is this? This part, right, we have a two control part for any register. Register is nothing, if you go in details, register is nothing but consist of D flip flop. So, we want to control the value of the D flip flop. So, we have in input 1 and output 1. Okay. So, that is all. So, we have a details diagram for this one. This is like the input and output gates from the register RI are controlled by the signal RI in and RI out, as I said. So, if you have a register here, so we will have a signal, let us say in, we have a control, this is we say is R in, and then we have a control, this is we say is the R out. So, that is we say. So, R in is set is 1, data available on the common bus are loaded into RI. Similarly, RI out also will be there. So, I think I should go here. So, with a diagram, that is I wanted to show you. So, let us say this is a D flip flop. So, here what do you want to do? We have a register R out. So, whatever the content I want to control the output of this D flip flop, and similarly input I want to control another called RI in. So, input is nothing but a select of the mask, okay, and here we have a tri-state buffer. So, now we have a value whatever the content of the bus. So, that I want to pass to the register. Then what I do? I choose this part. So, whatever the value it will come, so it will come here and it will pass here, okay, and it is a D flip flop. So, whatever the value it will transfer to Q bit, okay. But if this is high impedance, no value will go out. So, now henceforth what will happen, this is like a kind of feedback. So, now we will choose the value of 0. So, no value from the bus can enter into the D flip flop. So, therefore, if R in is 1, then it will take from the whatever the value in the bus. If it is 0, so simply it will be it will not take, and whatever the output value, that will be feed. Now, if you take out the value from the one register, say D flip flop to another one, what you do, Rj out equal to you put 1. So, earlier it was high impedance. Now, whatever the value, that will be placed to the internal bus of the processor. Okay. So, that is, this diagram is like put squeeze or whatever is there is like this part. Okay. So, here. So, this is 1 and this is 1, this is R in and this is Ri in and this is Ri out. So, now performing a arithmetic operation or logical operation. So, you know that ALU is a combinational circuit and it has no internal storage. So, let us say we want to do the operation like what is the sequence of operation to add the content of register R1 to those of R2 and store the result in R3. Basically, I want to do the operation R3, R1 plus R2. I want to do this operation. So, what are the micro operation we need to do? Okay. What are the micro operation? Add is a signal. So, we have to at right time you have to activate that, and content of R1 and content of R2 should be transferred to the ALU somehow, and then it add be operated, and the result will be stored to the Z register. So, we need to add to register content and then store to other register. Okay. So, what is the first step? What do we want to do it? R1 should be added with R2. So, what is R1? R1 is a register and you have one control part. So, we say R1 out, and then you have something is R1 in. So, you need to add this R1. So, therefore, you have to take out the value of R1 out. So, R1 out should be on. So, output of the register R1 and input of the register Y are enabled. Why? You have to go to the diagram. Okay. What is that you have here? So, what you have to do it? Let us say we have a register somewhere here. Let us say this is R1. Okay. So, R1 is connected something like here. We have, so R1 in, and then we have something R1 out. Okay. And then you have a register. You have a register R2. Okay. So, this is connected, this is connected, you have a control here, you have a control here. Okay. And then another register you have, let us say R3. Okay. So, you have a control here, you have a control here. Okay. This is simple diagram I draw. Now, what you want to do? We want to add R1 plus R2 and then result will store to R3. So, content of R1, first what you do it? R1 out should be on. So, then what will happen? Whatever the results of R1, it will be on the internal bus, and then what you do it? We will put Y in enable. So, Y in equal to 1. So, then value will come here, Y register value will come. Next what we have to do? We have to choose this line. Okay. So, therefore, we have to do select Y. So, let us say we have a select 0, select constant 4 and select constant select Y. So, we have to do select Y. So, then whatever the value of R1 now it is in this position. Now, you have to take out the value because it is in a register. So, value can be stored here Y1, no problem, internal this is a memory. Now, what we have to do? Value of R2 will transfer. So, again I have to write in the next clock cycle. I will tell you I am not using the term clock cycle. Next what I have to do? R2 out will be 1. So, then value of R2 will be internal part, and then there is a connection, it will come to B. once it reach to B and another value is reaching here. So, what we do now I select y. So, now from here it will come the R1 and from here it will come R2. So, after that select y, not here select. So, this is wrong. Okay. So, select y. So, this is first step, this is second step, this is in the first clock cycle, this is in second clock cycle. Now, what we have to do? We have to add. So, therefore, there should be a signal is add. So, then third step will be something, you should be add should be on. So, add should be on, add is a signal also. Next, what you have to do? Now, ALU will do the addition and it will store in the register Z. So, therefore, Z in should be 1. So, now result is stored here, but what you have to do? You have to store the result to R3. So, R3 is a register and this is a control line. So, which one should go on? R3 in should be on. So, therefore, R3 in should be 1. So, then only result will transfer, whatever results is there, then it will transfer to R3. So, just imagine that for this operation we need to do so many signals, okay, and it should be done sequentially. Some of the operation you can do parallelly, some of the sequential you have to do. See, let us say you cannot simply do R1 and R2 on at the same time, then it will be both value will be on the internal bus. So, it will be damaged. So, therefore, once R1 reach to Y, then only you can allow that R2, that means in the next clock cycle only you can allow R2. So, these are the signal required for the performing this what is called is this operation like addition operation. Okay. Now, we see where we were arithmetic operation. What is that? ALU is a combinational circuit. ALU gets the two operand from the mask as I said, and the bus, the result is temporarily stored in a register Z. Okay. Okay. Now, this is the operation I think. Yeah. So, the multiplexer select signal is set to select Y, causing the multiplexer to get to the content of the register Y to the input A. Whatever I said is written here or in the other way around. So, that is why first step you have to do R1 out, very fair, R1 out and Y in. Because why? You have to remember the diagram. Why? What is the diagram? You have to go back, because this is Y in, you have to on and then 1 should be out. That is why it is here R1 out and Y in. It is not in the same step. In the next step, what you have to do? R2 out, select Y and you add and it Z in. And in the next step, what you have to do? Z out will go to R3 in.